Hello, it's Dr. White. I'll give you a little background on the traveling salesman problem. I had this idea back when I was in graduate school. I wanted to take the traveling salesman problem and turn it into a physics problem and then see if I could solve it using in-body techniques and minimize the energy of the physics problem to find the minimal path. And so I got a couple of students to work on it, and this is many, many years later. First, we start working on Edwin Gonzalez and Stephen Lowe, and then Johnny C. picked up the problem after that. So the basic idea is we put a Leonard-Jones potential between each of the cities and have their natural length as the way they want to stay. And then we popped a wall around the cities, and then we put a smaller wall inside, and then we blew up the internal wall until it hit the outer wall, and it was supposed to push the cities into a loop, and then that loop would be the path, and was hopefully they would minimize the energy as they went out to this path, and that would give us the minimal path. So here's the simulation of that. And that is the minimal path for these 5 cities. And we got really good results with small data sets and with larger data sets that were put out on a grid. So what we want to do is take this to larger data sets. So that's when Johnny picked up the project. Now, with larger data sets, we had problems with this many objects pushed against the external wall. So what we did, we allowed the external wall to move in and out off of a type of pressure type model. So if they got too much force against the wall would move out. If it's too little force, the wall would move in. So we allowed the outer wall to move in and out with certain criterion, but basically the same idea. So we added pressure to it, and here's what we got from that one. So it's kind of hard to tell because we kept the wall the same. On the video, it's the same size. It's actually moving in and out, but we scaled it so we could keep it on the screen. The different colors tells you if it's like, if you believe yellow is staying still, and red's moving in and blue's moving out. Speed this up a little here. And there's the final path. And it worked much better than just the naive approach that we started with. Then another thing we noticed was that local clusters, this is the all the capitals of the states in the United States, but we noticed that local clusters were causing problems. So what Johnny did, he went inside, same basic idea. We got pressure on the outside, moving into the outer wall, moves in and out. We have an inner wall moving out, but along all the dense locations, he put another sphere and blew up all the locally dense places. So here's a video on that one. And I'll speed this up a little. And that's your path through the lower 48 state capitals. And without pressure, he was pretty far off of the perfect answer. When he added pressure, he was within 10%. And then when he added pressure in this density process where he blows up locally dense areas, he got within 9% of the current area. So that's the general idea of the work we're doing on the traveling salesman problem.